Okay, a different look at an example. Use the figure to evaluate the function given that h of x is equal to the tangent of x. Find h evaluated at 2 theta. So what this is telling us is to find the double angle of function h. So really, how you should see that is they're asking us to calculate the tangent of 2 theta. Which, before I even start anything else, I'm going to go pull my formula. So 2 tan theta divided by 1 minus tangent squared theta. Okay, so that's what I'm going to be working with. I'm obviously going to know need to know the tangent of theta value to calculate this formula. So I need to go do some background work to be able to figure that out. First of all, this figure tells me that I'm in quadrant 2. So if I wanted to go work with the triangle, I'm in quadrant 2, representative triangle. What is if this is like your x value and this is your y value, what is the height of this thing? 6. Good, because it was given to me in that ordered pair. And what's the radius? Square root of 40, right? Because this is x squared plus y squared is equal to r squared. So really, our radius is going to be the square root of 40. Now, we're left to find this missing side. So let's do Pythagorean theorem to find the missing side. Okay, careful when you do the square of a square root right there, you're just going to get 40. So my b is going to be plus or minus a 2. So does a positive 2 go here or a negative 2? Negative 2. Okay, so now we need tangent of theta to be able to calculate this formula. So let's figure out tangent of theta is going to be, it's defined to be your y over your x. So what's our y value? 6. And what's our x value? Negative 2. So what does tangent of theta simplify to? Something very nice. So that's good news. So now let's jump back over here to our formula and calculate the double angle. So 2, what do we get for tan theta? Negative 3. And that's 1 minus negative 3 squared. Negative 6 in the numerator. Let's calculate down here. What's a negative 3 squared? Positive 9. So what's 1 minus 9? I'm actually just going to write it so I'll have the paper trail for you. So the negative 6 over a negative 8 is going to simplify to 3/4. So I'm going to say tan of 2 theta is equal to 3/4. So also be able to calculate background information given a figure. That's something else you'll be working on. Alright, back to the solving equation stuff. This time we have an equation with a 2 theta in there. So let's just see how we can use some of the information we did today to be able to solve this. First thing we want to do is set this thing equal to 0 by moving this term over. So let's rewrite this. So it's going to be 10 cosine of 2 theta. And if I move this term to the left side, what is that? Plus 10. You'll change the sign if you move across the equal bar. Equals 0. Okay, if our goal is to get, let's see if we can get this cosine of 2 theta term by itself, because I have formulas to work with when I have this by itself. So what can I do to get this by itself? What do I need to do with this? Divide by 10, right? But whatever you do, you must do to everything in the problem. So our next step, let's divide everything by 10. So then that would give us cosine of 2 theta plus cosine of theta is equal to 0. Let me go back up here and make some notes. So set equal to 0. And then we divide by 10. Okay, so that's the things we've done so far. Now, this guy is what's familiar to you. It's one of the things we've been using today. So I can actually sub in for that. Now let's go back to our page where we have our formulas and decide which one's going to be best. Okay, so I have the option of a cosine squared and a sine squared. This has just the cosine, and this one has just the sine. Now if I flip back to what we're working with, I want to have them all in the same trig function. So I definitely don't want to pick one of the ones with a cosine in it, because then it's just going to have us in all different trig functions. So what we would like to do is have the one that's going to be all cosine. So I'm going to replace that in red with our 2 cosine squared theta minus 1. Just bringing down plus cosine of theta equals 0. Alright, now let's just reorder this so that it looks like it's in factored form. So if I had 2 cosine squared theta plus cosine of theta minus 1 equals 0. So here, let me put this in red, all we did was rearrange. Okay, arrange to set up for factoring. Now, if you recall in the previous lesson, sometimes it helped a few of you to do 2x squared plus x minus 1 equals 0 to factor. And if you like doing that method, you can do that. Okay, we're looking for what multiplies to give us a negative 2, but adds to give us a positive 1 right there. So multiplies to give you the outside, adds to give you the inside. And what would do that for us? What multiplies to give us a negative 2, but when we add them we get a positive 1. Well, 2 times a negative 1, that worked for us. Multiply them, we get negative 2. When we add them, we get positive 1. We always put it over the first term with the variable split, so a 2x and a 2x. Reduce a 2 out of each of these, so that becomes a 1. This is using bottoms up method. You're free to use any method you prefer. This would just give us an x plus 1. Here, nothing reduces or simplifies, so we write from the bottom up and we would get 2x minus 1. Okay, we can convert that back over here to our trig function by having, I would rewrite this as cosine of theta plus 1. So it's going to be cosine of theta plus 1. And what's this one going to be? 2 cosine of theta minus 1 equals 0. Now, do you remember what we did next? We said this term equal to 0 and solve, this term equal to 0 and solve. So my first one is cosine of theta plus 1 is equal to 0. I'll let you go ahead and get started working on that. And then you can do 2 cosine of theta minus 1 equals to 0. So we want to know, where does the cosine theta equal negative 1? And for this one, then we divide by 2. We want to know where the cosine of theta is equal to 1/2. Alright, so let's go. Let me see if I can pull up a unit circle. Okay, so we just pulled up a unit circle over here. Where's the cosine of theta equal to negative 1? Yes, at pi. So this one, cosine of theta equals negative 1 at pi. Where does the cosine of theta equal positive 1/2? That's going to be pi over 3 right there. Is there anywhere else? And what, 5 pi over 3 right here? Yes, so 5 pi over 3. Okay, and so we've done this before. We just didn't substitute with a double angle formula. So that's what's new to this lesson. Okay, our last one, 15 minus the sine of theta equals a cosine of 2 theta. Well, clearly we want to go here and determine which formula we can use to substitute for this. And if this side has a sine of theta in it, if we can get them in terms of sine only, we want to use that formula. So if you look back at your formula sheet, we can see that for the cosine of 2 theta, we're going to use 1 minus 2 sine squared theta. So this side I'm just going to bring down right here as is. 15 minus the sine of theta. What do you think we do next? Move everything to one side and set it equal to 0. Okay, so if I move this over, it's positive. I'm carrying that down, it's next. My 15 I'm carrying down, and this 1 is going to move to the other side, so it's a negative 1. And if it's okay with you, I'm going to go ahead and simplify that so that I have a 14. Now what you want to do next is just rewrite this, if it helps you, to go 2x squared minus x plus 14 equal to 0, so that you can work on factoring that. Alright, let's just see. 2 times 14 is 28. We want two numbers that multiply to give us 28, but when we add them we get a negative 1. Alright, is there any way, here's factors of 28, that when we add them or subtract them together, we'll get a negative 1? These two numbers in any kind of way won't give us a 1. Neither will these if we add or subtract these, or these. So this does not factor. That means you would have to use the quadratic formula to solve this. Okay, so if we did quadratic formula, our A would be 2, our B is negative 1, and our C is 14. And if I wrote my quadratic formula down and plugged it in, I want you to know that if you don't remember this from algebra, that this is called, under this radical, this is called the discriminant, and it tells us about our solutions, okay? So before I actually calculate this whole thing, I can check my discriminant and see what I get there. Well, this is 1 squared. Negative 1 squared, which is just going to be, I'm only looking at the discriminant right now, would be a positive 1. And then negative 4 times 2 times 14 gives me a negative 112, which the discriminant would simplify to a negative 111. A negative value under the radical just means it's not a real solution. So I don't even have to calculate all the rest of this out. This is no real solution to this answer, or not a real number. So I'm going to say no real solution. Now, if you didn't remember properties of your discriminant to do that, you would have just calculated this entire thing out, and you would have got a similar, when you run into a negative radical right there, you would have got no real solution as well. If this were positive, you would have to go back and calculate to get an actual number.